Hello everyone, I am Professor Vaibhav Shah. Welcome back to yet another lecture on engineering course. In today's lecture, lecture 27, we are going to learn involute of a circle for unwinding of a string. There are many types of cases possible like involute of a square, involute of a pentagon, involute of a hexagon, and so on. In subsequent lectures, we will be learning each of these types one by one. If you like my content and teaching style, then do not forget to like and subscribe to show your love and support. And try to share it with your friends, which might help them to clear their concepts. Let's start with one of the problems. Problem 1. A string is unwound from a circle of 20 mm diameter. Draw the locus of the end point of string P for unwinding the strings 1 turn. String is kept tight during unwinding. Draw the tangent and normal to the curve at any point. So in this case, we are unwinding the string. So that means this operation is unwinding operation. And for this operation only, we are dealing this special case. So we are unwinding the string from the circle. In previous case, we have seen all the winding operation cases, but there is a difference between winding and unwinding. So that's why we have selected this case specifically for unwinding operation. So here circle is given with a 20 mm diameter. As usual, we are having one circle with a given diameter. We have to draw the locus of end point of a string P. So whenever you see this word end point of P, you have to trace. That means you have to draw your involute. Now here we have to also draw the tangent normal at any point. So we'll see the tangent and normal afterwards after finishing the drawing of your involute. So now let us first define our assumptions. So first assumption is we are unwinding the string. So this is unwinding of a string case. Now here the length of the string is exactly equal to the circumferential length. It may be less than your circumferential length or it may be greater than your circumferential length. But it doesn't matter in this case because we are just dealing and we are just showing that how to draw if your example is given for unwinding operation. And you can apply each of the separate cases from our previous example to this unwinding operation. The change would be the numbering pattern. So let us observe the change of the numbering pattern for this unwinding operation, else your example would be completely identical to your previous examples. So now let us first find out the required length of string. So now you will ask, sir, what is the required length of string? So let me clarify you. The required length of string is nothing but the length of string which is required to cover the complete circumference of your circle during your winding or unwinding operation of your string. So here the required length of string is nothing but your pi d. So pi d means your circumference of your given circle. So here given circle diameter is given as 20 mm. So we'll just put 20 in the place of your diameter and we'll be having 62.83 mm. So this is nothing but the required length of string which we need to cover the complete circumference of a circle during our operation. So now let us start the example. So first of all, we'll try to draw this circle with given diameter. So your diameter is given as 20 mm. That means you will set on your rounder 10 mm and you have to draw 10 mm as a radius circle, or you can say 20 diameter circle. After drawing this circle, we will either divide this circle into 8 number of equal parts or 12 number of equal parts. So here I have divided this circle into 8 number of equal parts. You can use 45 degrees set square to divide this circle into 8 number of equal parts. After drawing this circle, you have to draw one tangent line from either from the top of your circle or your bottom of the circle. In previous example, we have drawn all of the lines from the bottom of the circle, which is also okay. And if you try to draw the line from the top of the circle, horizontal line, which is also okay. You can select any way, whichever is convenient to you. So in this case, we are drawing this horizontal line from the top of the circle. Now this line represents the line of required length of string. So our required length of string is pi d. That means this line is of 62.83 mm. So you have to draw this horizontal line of your pi d distance, which is nothing but your 62.83 mm. Now after drawing this line, we must divide the line of pi d distance or your circumferential distance into same number of equal parts in which we have divided this circle. So if we have divided this circle into 8 number of equal parts, then we must divide this horizontal line of pi d distance also into 8 number of equal parts. So let us divide this line into 8 number of equal parts. Now we'll give numbering obviously from this 0 point. Why this is a 0 point? Because this is a connection point of your string with your circle. So it is also known as your initial point or your start point. So that's why we are defining this point 0 on your string as well as 0 on your circle. So after defining this 0 point, you will give numbering 1, 2, 3, 4, 5, 6, 7 and 8 on your string or a horizontal line. Now let us give numbering pattern to this circle. Now this is the example for unwinding operation, and the numbering pattern for circle changes for winding operation, and it is different from your unwinding operation. So now let us give focus to the numbering pattern, and it is most important point. If you miss out this numbering pattern in the case of winding or unwinding operation, you will end up with your wrong example and you will lose marks. So let us observe keenly. Here I have specified this 0 point. Now in this case we are actually unwinding the string. So what does it mean? So we have actually wound round the string completely on the cylinder previously. Now we are trying to unwind the certain portion of the string from your cylinder. So let us observe in this case, let us think that we are unwinding the string from the cylinder from the portion of 1, 0 of the cylinder. So we have selected this portion and we will try to unwind the string in anti-clockwise direction like this. So we have pick up the string from 0 point and we try to unwind until your point P1. So we will have this portion of string unwound from your string. As you can see, this portion of string is now unwound, or it is being detached from your circumference of the circle. So now this is the string length. So here the logic is the string gets unwound from this point first. That's why we have denoted this point as point number 1. So once again we try to unwind the string from this circle. So let us suppose in first case we try to unwind the portion of string from 1 till 0 like this. So we have unwound this string. So the end point of the string would be now P1 point, and the string length would be, unwind string length would be 0.1 till your P1 point. So this is your actual string. We have unwounded from the cylinder. So now it gets unwounded from around this first portion of your circle. That means it will get unwound around this point first. So that's why we have denoted this point as number 1 on the circle. So now this is point 0 and this is point 1. Then it clarifies that our dimensioning pattern or numbering pattern would be anti-clockwise. So let us follow this pattern: 0, 1, 2, 3, 4, 5, 6, 7 and 8. So this is the pattern which I was telling you about. You have to just remember the logic of this unwinding operation and you will have correct pattern for each of your examples. Now we are almost done. So now you have to just simply draw tangents from each of the point, from point 1, from point 2, from point 3, from point 4, from point 5, from point 6, from point 7 and from point 8. The line is already drawn. Now you will ask, sir, how do I draw the tangents? So let me clarify you once again. So you have to simply draw the line perpendicular to this line of 1 like this, so it will be the tangent. You have to just draw a line perpendicular line to this, then this will be the tangent. You have to draw the line perpendicular line of 3, then you will be having tangent, and likewise you will have each of the tangents. Now next step. So now we are unwinding the string. So let us suppose that in the first stage we are unwinding the string from 0 till 1. So let us take out our rounder and put your rounder and select the distance of 0 to 1 on this horizontal line and put your rounder at point number 1 and try to cut the tangent line of this 1. You will have this P1 point. Now let us understand, if we are trying to open the string or unwind the string from 2 till 0, then it will be the distance of 2 till 0 on the circle. So take the equal distance of that circle on this horizontal line from 0 till 2 on your rounder. Put your rounder at point number 2 and try to cut this line here. You will be having point P2. From point number 3, so we are assuming that we are unwinding the string from 3 till 0. So for that we will be having complete string length starting from 0 till 3. So for that, let us go to the string and take the dimension of string from 0 till 3, which is the portion we are going to unwind. So after selecting the distance between 0 till 3, we will try to cut this line here. So it will give us the point P3. So we have to put our rounder at point 3 and we'll try to cut this line here by taking the distance of 0 till 3. Now for point 4, take the distance of 0 till 5 because we try to unwind the string from 0 till 5. So total string length would be 0 till 5 on the circle. So same string length would be on the horizontal line also. So for that, we'll be taking the distance from 0 till 5 on our rounder. Put your rounder at point number 5 and try to cut this line. You will be having this P5 point as an end point. Now for point number 6, we are trying to unwind the string from 0 till 6 now. So we'll be taking the distance of 0 till 6 on your horizontal line on your rounder. After getting that distance, go to this point 6 on this circle and try to cut this tangent line of 6. You will be having this point as P6. Now for P7, what we'll do is we'll try to unwind the string from 0 till the point 7. So that's why we'll be taking the horizontal line from 0 till 7 and on our rounder. After getting this point, we have to go to this point number 7 on the circle and try to cut this tangent line of your point 7. You will be having this point P7. And for P8 point, it is obvious that it will be the complete length of string and it is the last position and you have now completely string open position. So now this will indicate your final point P8, which is the total final point. So now let us observe logically. So this is the string length at the first point. Now string is open for the two divisions 0 till 1, 1 to 2. So we are having additional string length open. Now let us observe for 3. So we'll be having 0 till 1, 1 to 2, 2 to 3. The total string length would be this. Now for point 4. So we'll be having 0 till 1, 1 to 2, 2 to 3, 3 to 4. The total string length would be open like this. So these are nothing but the different position of string in open condition. And finally, you will be having your final string open. So this is your final string length, which you can see. Now, let us come to the final part, which is draw the tangent and normal to the curve at any point. So now let us select any point for drawing the tangent normal. So in this case, let us suppose I have selected this point S between your point P6 and your point P7. So this is my point S and this is the point at where I want to draw my tangent and normal. So this is the point I have selected. After selecting this point, you have to just simply connect this point with your center point of the circle. So I have connected this point S with the center point of the circle. After that, you have to just find out the center point of this line. So S and your center point of the circle, you have to find out the center point of this line. So how would you find out the center point of the line? So very simple. You can either use your bisection of line method or you can directly calculate from your calculator the value exactly and you will locate this point. But mind that you have to select that point accurately. If your point distance is wrong, then you will have the wrong tangent and normal and which will cut your marks. Now, after drawing this center point, next task is simply we have to draw one semicircle. But wait, we can draw semicircles on either side of this line, S and your center line. We can draw semicircle on the right hand side of this line, like this we have drawn, or you can also draw the semicircle on the left hand side of your line. Then you will ask, sir, why you have drawn your semicircle on the right hand side? So let me clarify you the logic. So here, let us observe our point at where we want to draw the tangent normal. We have selected between point P6 and P7. You can observe this point is in between P6 and P7. So this says that your semicircle which you are drawing on the right hand side or left hand side, which must pass from a point on the circle between 6 and 7. So as you can see, my semicircle is passing between the 6 and 7 point on my circle. So that's why I have drawn my semicircle on the right hand side. So once again, we have selected this point between P6 and P7 that suggests that your semicircle from the circle must pass from your 6 and 7. You can see this is my semicircle and it is passing between your point 6 and 7 on your circle. Now, next question, sir, how do I draw the semicircle? What is the radius of the semicircle? So let us take the radius of the semicircle. So take out your rounder, put your rounder at the center point and take the radius from center point till point S and try to draw your semicircle. So once again, you have taken the center point till your S point distance. So center point till S point, your distance is your radius. And after that, you will draw the semicircle and the semicircle must pass from 6 and 7 point on the circle. Now, after drawing the semicircle, what? So now after drawing the semicircle, the next task is very simple. So you will be having semicircle intersecting your circle at any point. So this point, mark this point and call this point as a normal point N. So this is nothing but your normal point. Now connect your normal point with your selected point where you want to draw the tangent normal. So connect your normal point with your S point and extend this line, which will give you normal, which is given by N line. And to the normal, draw one line 90 degree to this normal, which will give you TT line, which is also called as the tangent. So this is nothing but your tangent and normal. So once again, we'll be having this semicircle intersecting this circle somewhere here. So mark this point as point N. Connect this N point with your S point and extend this line. You will be having normal and try to draw 90 degree line at the same point. You will be having normal and tangent. So this is a normal and tangent at our any given selected point. We can draw tangent and normal. So this is all from my side. If you have enjoyed my lecture, then do not forget to like and subscribe to show your love and support. Keep learning, stay connected. Bye-bye.